All right, so today we're diving deep into event sourcing. It's one of those topics that seems to be everywhere, and there are a lot of opinions about it, so we're going to cut through the noise and help you understand what it's really all about. Our guide for this deep dive is an article called Event Sourcing by Mario Bittencourt from Essence Tech on Medium.
Yeah, that's a great starting point.
Yeah, so we're going to be exploring what event sourcing is, and maybe more importantly, what it isn't, and how it actually works and why it should matter to you. Get ready to discover how event sourcing can basically be like having a time machine for your data.
That's intriguing.
Okay, so first things first, what exactly is this event sourcing thing that everybody's talking about?
Well, the article gives us a pretty solid definition. It says that in event sourcing, an application's state, it isn't just stored as it currently exists. It's actually reconstructed by replaying a series of events.
Okay, I think I get that, but what does that actually mean in a practical sense?
So think of it like trying to debug, a really complicated financial transaction. With a typical system, you might only be able to see the final state, you know, the messed up state. But imagine if you could rewind and replay each step in the transaction, every single deposit, withdrawal fee, everything. That's kind of the power that event sourcing can give you, a complete and auditable history of how you got to that current state.
So it's not just about like where you ended up, it's like the entire journey.
Precisely.
Okay, got it. Now, the article mentions three key components that kind of make up this world of event sourcing: entities, events, and the event store. So can we break those down a little bit?
Sure. Entities are kind of the stars of the show. They're the objects or the things in your system that have data and behavior.
Yeah.
Events are the actions that actually change those entities. You can kind of think of them as plot twists in a story.
Yeah.
And then the event store, that's our memory bank. It's diligently recording every single event that takes place.
All right, so it's like a super detailed log of everything that's ever
Yeah.
happened. All right, I think I'm starting to get a picture now. The article uses figures 1 and 2 to contrast how data retrieval works in a typical application versus an event sourcing application. Can you walk us through that a little bit?
Sure. In a typical system, which is what you see in figure 1,
Hmm.
you would just fetch the latest state of an entity. It's like grabbing just a snapshot in time. But in event sourcing, which is figure 2, you're retrieving all of the events related to that entity in chronological order. So you're not just seeing, now you're seeing the entire timeline of how it got to its current state.
That's a really great way to put it. It's like the difference between, looking at a single photograph versus watching a video of everything that led up to that moment.
I like that analogy.
Okay, cool. Now, with this whole idea of the timeline in mind, how does this actually work when you're trying to create, update, or even reconstruct an entity? In this world of event sourcing,
Well, the article kind of outlines the event sourcing lifecycle with a few helpful visuals in figures 4, 5, and 6. Let's just take creating an order as an example. When you issue that command, an event is created capturing all the details of the order, like the items, the shipping, address, everything. That event then updates the order entity's state.
so the event isn't just like a notification, it's what actually drives the change.
Exactly. And that's really the crucial part, because that event also gets permanently recorded in the event store. And that becomes like a building block in the history of this system.
Okay, so we have this log of events that's constantly growing, but how do you actually use that to figure out what the state of something is?
So let's say you want to see the current state of an order, instead of just fetching a snapshot. The system replays every single event associated with that order, from creation to now. And each event modifies the order entity's state step by step until you arrive at the current version.
So even if there were like tons of changes to that order, like shipping updates, item additions, whatever, you could replay all of those events and basically watch that order evolve over time.
Exactly. Each event is like a time-stamped instruction, telling the system exactly how the entity's state should change.
That's powerful. I can already see how valuable that would be for debugging and auditing, especially for those systems that can get really complicated with lots of moving pieces.
Definitely. And updating an entity follows a really similar process. So let's say you need to change the shipping address of that order. A command is issued. The entity generates an event detailing the change. It applies it to its own state. And again, that event is added to the order's event stream in the event store.
So the event store is just constantly growing, creating this, super comprehensive history of everything that's happened.
It's an ever-expanding record.
Okay, so the article briefly mentions CQRS, which stands for Command Query Responsibility Segregation, I think. What's the connection there and why is it important?
So remember how we were just talking about reconstructing an entity's state by replaying all the events? That's a great system for certain scenarios.
Right.
But what if you need to generate a report or do some analysis across a ton of entities. You know, replaying every single event for every single entity. That wouldn't be the most efficient way to do things.
So that's where CQRS comes in.
Exactly. It's a pattern that's often used alongside event sourcing. To handle those different types of data access, it separates how you update the state of the system, the commands, from how you read the data, the queries.
Okay, so commands are about changing things and queries are about getting information.
Precisely. And by
Wow.
separating those two things, it allows you to optimize each path separately. So for example, you can use that event replaying for handling the commands and updating the system state. But then for the queries, you can create what are called specialized read models
Yeah.
that are specifically designed for retrieving that data really quickly.
So what are these read models and how do they actually work?
Let's say you want to generate a report on total sales by region. Instead of replaying every single sales event, you could have a read model that's literally designed just to answer that question. It might be pre-calculated or indexed differently, or even structured in a way that makes that type of query much faster.
So it's like having a special database view that's just tailored for certain types of reports.
Exactly. It's about having the right tool for the job.
Now, before we move on, I want to talk about a couple of common myths about event sourcing that the article debunks. The first one is that if an application uses events, it means it's using event sourcing.
Right.
So what's wrong with that assumption?
That's a really common misconception. Just because your system might have events in it doesn't automatically mean you're doing event sourcing. Many systems use events for other things like communication or triggering actions, but they're still relying on storing the current state and not the whole history of changes.
So the key is how you're using those events. Are you actually saving them and then using them to rebuild your state?
Right. Event-driven architecture and event sourcing, they're related, but they're not the same thing.
Okay, that makes sense. The other myth the article mentions is that event sourcing is inherently slow because of the whole replaying events thing.
Yeah, again, that's understandable why people might think that.
Yeah.
But in reality, the performance really depends on how you're accessing the data and who is accessing the data. If you're just trying to retrieve a single entity by its ID, it can actually be really fast, especially if you're using some technologies that are specifically designed for efficient event storage and retrieval.
So it's not about like literally replaying every event every single time.
Right. And if you do have a situation where you have just a ton of events, there are some optimization techniques you can use, like snapshots. You think of a snapshot like a checkpoint, like a pre-calculated state of that entity at a specific point in time. So instead of replaying all the events from the very beginning, you start at the snapshot, and then you just replay the events that happen after that.
So it's like fast forwarding through history.
Exactly.
Are there different types of snapshots?
Yeah, there are full snapshots.
Yeah.
Which capture like the entire state of the entity. And then there are incremental snapshots, which just store the changes since the last snapshot was taken.
So to get the full picture, you'd start with a full snapshot and then apply any incremental snapshots on top of that.
Exactly. Incremental snapshots are much smaller.
Yeah.
And faster to create. But you might have to apply multiple ones to get the most up-to-date view.
So it seems like event sourcing doesn't have to be slow. There are things you can do to optimize.
Right. It all depends on how you set it up. All right, so far we've covered a lot of ground. Let's do a quick recap of what we've learned about event sourcing so far. So it's really all about capturing the history of changes in your system, not just the current state.
Like a really detailed audit trail.
Right. And that history is stored as a series of events in a special place called the event store, which can then be used to replay and reconstruct the state of the system at any point in time.
Gives you a lot of power. Yeah. We also talked about CQRS, which helps address the challenge of having different ways to access the data. We need to be able to both change the system and retrieve information.
Right.
And then we debunked a couple of common myths, highlighting that just because you're using events doesn't mean you're doing event sourcing, and that event sourcing doesn't have to be slow.
Right.
So we've laid a really good foundation here. So next, we're going to move on and explore some of the more advanced aspects and dive deeper into how this actually works in practice.
Sounds good. So I think we're really starting to see just how powerful event sourcing can be. It's not just about storing data differently. It's like a fundamental shift in how we think about our systems.
It's like moving from this, static view of data to one that's much more dynamic, where we're actually embracing time and how things change.
Exactly.
Yeah.
And that shift opens up a lot of exciting possibilities.
So the article doesn't really get into like the technical nitty-gritty of implementing this, but it does highlight some important things to think about. And one of those is this idea of snapshots, which we touched on a little bit earlier.
Yeah, snapshots are a really important optimization technique
Mm.
for managing performance in these systems. Reconstructing an entity state. It involves replaying the entire history of events. And while that's super valuable for accuracy and auditability, it can become kind of a bottleneck as the number of events starts to grow.
Especially if you're dealing with entities that have a really long history, or if you need to reconstruct the state pretty frequently.
Exactly. And that's where snapshots come in. Think of a snapshot like a checkpoint. It's a pre-calculated state of an entity at a specific point in time. So instead of replaying every single event from the beginning of time, you can just start from that snapshot and only replay the events that happened after that point.
Also, it's like fast forwarding through history.
Precisely.
Okay, so that makes sense. But how do you decide when to actually create a snapshot, and what kind of snapshots are there?
That's a great question. The frequency of snapshot creation really depends on a bunch of factors, like how often the entity changes, performance requirements, storage considerations. You might create snapshots after a certain number of events, or at specific time intervals, or even based on certain events that happen.
So it's like a balancing act.
Exactly. Now, in terms of types of snapshots, there are two main ones: full snapshots and incremental snapshots. A full snapshot basically captures the entire state of the entity at that moment. It's like taking a full backup.
So if you had to restore from a full snapshot, you'd have everything you need.
Right. An incremental snapshot is a little different. It only stores the changes since the last snapshot, so it's more like a patch.
So you would need both a full snapshot and then any incremental snapshots to get the full picture.
Precisely. Incremental snapshots are generally smaller and quicker to make, but you might need to apply a bunch of them to get the latest state.
Okay, so it's another trade-off situation.
Yeah, storage space versus processing time.
Okay, I get it. So choosing the right snapshotting strategy is really important for performance.
Absolutely. You really need to understand your data and how your application uses it.
Now, another thing the article mentions is about designing your events.
Oh, yeah, this is huge. Event design is absolutely critical to making event sourcing work well. Remember, events are like the building blocks, so they need to be well-defined and consistent.
So they need to be treated like any other critical piece of data.
Exactly. Every event should represent a complete unit of change, with all the information you need to understand what happened and how it affected the system.
So for example, if we have an event that's about an order being placed, it should have all the details of the order.
Right. Items, shipping, address, payment information, timestamps, everything.
Okay.
And events should be immutable, meaning that once an event is created, it can't be changed.
Oh, that makes sense. You wouldn't want someone to be able to go back and mess with past events.
Exactly. Especially in a system where auditing is important.
Right.
It helps guarantee that the history is accurate and reliable.
Okay, now, the article talked a bit about versioning events. Can we dig into that a little more? Why is that important in event sourcing?
Well, as your system evolves over time, the structure of your events might change as well. You might add new features or modify existing ones.
Right, so what happens when you have these older events that are in a different format than your current events?
That's exactly where versioning comes in. By giving each event a version number, you can make sure the system can always interpret and replay those events correctly.
So it's like having a translator for your events.
I like that.
Okay, so versioning is all about managing those changes over time.
Exactly. It's essential for making sure that an event sourcing system is robust and reliable.
Okay, let's talk about CQRS again for a bit. It seems like a really important concept for getting the most out of event sourcing.
Absolutely. CQRS is all about handling those different ways that we access data.
Right, like we have the commands that change things,
Yeah.
and then we have queries that just retrieve information. But
Mhm.
how does that actually work when you're building a system?
Okay, let's imagine we're building an online store using event sourcing. When a customer places an order, that's a command. And that triggers a bunch of events, which update the order and then get stored in the event store.
So that's the normal event sourcing flow.
Right. But now let's say you want to show the customer their order history. That's a query.
And replaying every single event for every single order would be crazy.
Right, especially if they've placed a lot of orders. That's where CQRS comes in.
Mm.
Instead of using the event store for queries, you create a separate read model that's designed just for getting that order history. It could be a database table, a cached data structure, or even a pre-calculated view.
You said denormalized. Can you explain that a little?
Sure. When we design databases, we usually try to normalize the data, which means organizing it to avoid redundancy. But with read models, we actually do the opposite. We denormalize the data. So we combine data from lots of different tables into one.
So instead of having like separate tables for customers and orders, you might have one big table with everything you need to show the order history.
Exactly. It makes querying much faster.
Okay, so commands go through the event store, and queries are handled by these special read models.
Precisely.
So you're basically choosing the best strategy for each way you need to access the data.
Right. It's about optimizing for both performance and consistency.
So CQRS can be complicated, but it sounds like it's worth it for certain systems.
It really depends on your needs.
You mentioned before that event sourcing is really good for systems where auditing is really important.
Oh, yeah, definitely. Think about industries like finance, healthcare, or logistics. Tracking data is super important in those fields.
Because you need to be able to prove what happened when and who did it.
Exactly. Imagine a financial trading platform. With event sourcing, you could reconstruct every single trade, see every modification, and understand how decisions were made.
That would be incredibly valuable.
Yeah. Or think about healthcare. Being able to track every change to a patient's record would be huge.
Yeah, for safety and compliance.
Right. Or even in a logistics company. You could track the movement of goods, see where the bottlenecks are, and optimize delivery routes.
So event sourcing gives you this transparency and traceability.
Exactly.
Now, I'm curious about how this all plays with distributed systems, like with microservices.
That's a great question. And it's an area where event sourcing can really excel.
Because in a distributed system, you have all these different services that need to talk to each other.
Right. And events are a natural way to do that.
The services can basically announce changes that have happened.
Exactly. And other services can listen for those events and react accordingly.
So it creates this loosely coupled system.
Right. The services can evolve independently.
And since it's asynchronous, it can also help with resilience.
Yeah. If one service goes down, the others can keep running based on the events they've already received.
So it's a really powerful way to manage data in a distributed system.
Especially in a microservices world.
Okay, so we've been talking a lot about the benefits, but I think it's important to acknowledge that event sourcing isn't a silver bullet.
You're absolutely right. It has its trade-offs.
Mm-hmm.
And you really need to think carefully about whether it's right for you.
For example, it can be a little more complex to set up.
Yeah, it's a different way of thinking about how you design your system.
It's a shift in perspective.
Right. Instead of focusing on the current state, you're thinking about events and how those events change things over time.
And there's a learning curve there.
Yeah, even though there are tools that can help, you still need to learn the concepts.
And querying data can also be a little more complex.
Yeah, if you need to run complicated queries or analyze a lot of events, it can take some extra planning and optimization.
But that's where CQRS and read models can help.
Exactly.
So it's not that you can't query the data, it's just different.
Right. And it's important to remember that event sourcing doesn't have to be all or nothing.
Right. You don't have to use it for your entire system.
You can start with certain parts.
Yeah.
Like areas where auditing is crucial or where you have really complicated business logic.
So if you want to build systems that are more resilient, scalable, and auditable, event sourcing is definitely worth checking out.
You have to do your research and make sure it's the right fit.
It's a powerful tool, but it's not for every job.
Exactly.
It really sounds like event sourcing can change the game, but it's not something you just jump into.
Yeah, you got to be thoughtful about it.
So for our listener out there who's maybe intrigued by this whole event sourcing thing, but isn't really sure if it's right for them, what are some questions they should be asking themselves?
Well, I think the first thing is to really think about your core needs. Does your application need a super strong audit trail? Do you need to be able to go back in time and see how things changed? Or analyze how data has evolved? Those are situations where event sourcing is really going to shine.
Yeah, like having a time machine for your data.
Exactly. Another thing to think about is the complexity of your domain. If you have a pretty simple application, event sourcing might be overkill. But for more complex domains, like financial transactions or healthcare records, it could be a huge help.
So it's not just about using events, it's about the kind of events and how much detail you need.
Right. And then there's the performance aspect. Event sourcing doesn't have to be slow, but it does require you to think about data access differently.
We've talked about snapshots and CQRS.
Right. Those techniques can help a lot, but they also add some complexity.
So it's all about trade-offs.
Exactly.
So it sounds like event sourcing is a really powerful tool, but it's not the right tool for every job.
Exactly.
So as we wrap up this deep dive, what's one final thought you'd like to leave with our listener?
I'd say really think about the concept of time. You know how the state of a system changes over time? That's what event sourcing is all about.
Yeah, it's like the difference between a photo and a movie.
Exactly. And that shift in how you think about things, it can really open up some amazing possibilities.
So, to our listener out there, if you're looking for a new way to think about your data and how you build your applications, definitely explore event sourcing. You might find that it's exactly what you've been looking for. It's a really fascinating topic. And we've just scratched the surface here. Thanks for joining us on this deep dive. And until next time, keep exploring, keep learning, and keep diving deep.